Hello guys, I guess we are live. Okay, give me a second and while I just get my stuffs ready. Yeah. Okay. So okay, so as usual, we'll start with a recap of what we did yesterday. So yesterday we started off with a form submission, in which we discussed how client-side information can be vulnerable, how we can exploit hidden form fields, and what are referrer headers, and how actually it is used to sometimes make the attacks weak enough. Then we looked into an example of how we can use this input field, hidden input fields, along with the session ID to modify exploit the vulnerability in the system. I'm audible, right? Just wanted to confirm if I'm audible. Am I audible? Yeah, just let me know. I'll start once again. Okay, now we saw a PHP example too and how to avoid having a GET request for posting something into the web database. Uh, okay, we then did see some of the attacks on authentications, authorization, uh, code injection. Authentication attacks, we did go through the theoretical part of path traversal attacks. Then we did an automatic directory listing abuse, as in just the theory, followed with an injection attack, a little bit of SQL injections. Okay, so we'll be covering today the OS command attacks, which will be focusing on the system calls. Then we proceeded forward with SQL and XSS attacks. So we did understand what SQL is, how it is used, and how can we exploit it when there is a vulnerability provided to us. Okay. We looked at 1 equals to 1 technique in which we were able to bypass authentication. Uh, Following that, we saw how to understand if there is an SQL injection possible or not. Some of the methods to prevent it. Then we further rounded off the session with cross-site scripting, a little bit of theory, and then hands-on. Okay. So today we'll be going through application security. Okay. So we'll start with application security today. I guess there are very less number of people today. Okay. Let it be. Okay, so for application security, before discussing actually, I have posted a puzzle on Slack. Try to decode it. So the first line that you'll encounter is this big line. To understand the whole puzzle, you'll have to actually decode the first line. And I'll give you a hint as to this is one type of encoding, and you will be able to guess or figure out by knowing these three equals to sign. So if you know what type of encoding has appended equal to signs at the end of it, you'll be able to decode this back. And once you decode this back, you'll get to know what to do in the question. And inside the question, there are multiple data lines that are provided to you, and you'll understand how what to do with these. The last line is, can you solve this before this given number? So this should be something related to, I guess you'll be able to figure what this thing is. Else, if you can just, I guess, try searching this number online, you might somehow get towards the answer. Okay, then we'll start with, okay, fine. So we have been procrastinating doing this browser development tools, and I guess today is a good time to do this. Okay. So as we discussed in day 4 and day 5 about web applications, we actually didn't look into how browser helps us as an attacker to understand the system and find out vulnerabilities, right? So we'll try that out right now. Okay. So we'll go to say google.com. For google.com, it has very less data on its web homepage. So we'll proceed with say yahoo.com. Okay. So there are much more. Now, what I generally ask people to do is try getting into the source code of this file. Try looking into the source code of this file, and you will get a huge list, but don't think that you will not be able to comprehend this data. I don't even ask you to understand the whole data as such, but try to look into some of the things as to how it is done. What I would do is, once I go to the source page, I basically search for passwords. There are no passwords. Then I sometimes check for APIs. Okay, so there are API calls, but these are for the links and names. Okay. Then I would search for multiple different things that you are really interested in. But apart from this, the best part about browser development tools is, say you have the developer tools. So you can use the shortcut as well. But since people are unaware of it, I just went through the normal process. So the first thing today that we'll be discussing is elements, then we'll go to console, sources, network, and at last we'll just test the application part. So what elements does is your current display of your browser. Okay. So this is your current display that you are getting on your browser. And that exact replica is not replica. The content in terms of it is shown in terms of HTML. Okay. So this whole thing is shown in terms of HTML. Now, if you want to go through each and everything, you can just go to HTML and expand recursively, and it will just open up everything. Instead of opening each headers, you can just go to HTML and expand recursively if you want. But this is sometimes not that good to look at because it is very overwhelming. So we'll go to console here. So what console does is it is an interactive method to interact with the browser. So there are things that the developer might want to convey to people, and there are things that provide an error message. Say this thing is not able to be loaded into the browser. And that is why you are getting these red color things. The yellow colors are the warnings. Okay, fine. Then we'll go to sources. We'll come back to console and see how is it important. Now we'll go to sources. Now sources is all the files that are in the server side, which were pulled to your client side, and now those are being used to display you the web page. So there are multiple files that you can look into here. Okay. But instead of sources, networks is the place where it really gets interesting. So once you go to network, you'll have to actually refresh it. So once you refresh the page, you see all these are the requested files that you get. So there are multiple files. There are, say, XHR files. There are JavaScript files, CSS files, image files, media files, etc. Now, particularly here, we are not interested in CSS, image, and so forth because they are just static. The ones that are dynamic and that we can play with is the JavaScript files and the XHR files. Now, XHR is XML HTTP request. It is basically Ajax calls. And JavaScript files are the two files that we can play with. Now, say I want to know what one of the file does. Okay, let us choose one of the file. Okay, say any. Okay. When we click on the file, we get to see here that. Okay, so we get to see here. I'll just full screen it. Okay, it's still. Okay, it's still not that good. Okay, as you can see here, this is a header. 1 second. Okay. So this is a header which says what are the request URL, what is the response headers, and the data as in all the data that are contained in the headers are displayed here. Then we can go to preview. So this is a preview of this current JavaScript file that we just clicked. And this is the response. Okay. Now, this one-line JavaScript file is sometimes called as obfuscated or minified version of JavaScript file. And it really gets hard to read this. So you can use this pretty print button, which is a closed and open and closed parenthesis bracket, curly bracket, that makes it somewhat readable for you. Okay. Now this is still not readable in the sense you'll not be able to understand each and every function. Right? Now, say we are on some other file. Some good file would be okay. So this homepage would be a good file. So you can see these are multiple functions that are inside this file. But JavaScript files, you can search for API keys. So there are no API keys here present. Because the way this page was implemented is they used XHR to implement API keys. So when you go to XHR files, as in the files XHR filter, you see data displayed in various columns as name, status, type, and initiator. Now, the initiator is the one which called this request. So we'll try to go and see what this initiator does. So we'll just click on the initiator and it will take us to its actual place. Then we'll pretty print it. Okay. Now we can see that this is the place where this HTTP request was called. So let's jump back there once again. So this is the place where HTTP request was called. So you can meddle with all these stuffs and get to know JavaScript. I just wanted to let you know how this works. And there are something called as global listeners, which make sure that when you interact with the web page, you are responded accordingly. So say there is, so on key down, there are something that you will be displayed. Then on page show, there are stuff that will be displayed. Okay. So this is just normal web playing with web security, and I didn't discuss this in the previous class, so I thought of discussing it today. So we'll move on with normal application security for today's class. So we'll move on with, okay, so in general, what are errors, bugs, and failures? So these are something that does not work as expected. Now, when you say does not work as expected, what do you mean by work? It might be the way it behaves or the way it performs. So it might either crash, provide incorrect execution results. There might be backdoors which shouldn't be there, and that is why it does not work as expected. It might perform, which provides hangs, etc. Then you say as expected, right? But according to whom? So according to the programmers, if it provides unexpected behaviors, it is one of these, the errors, bugs, and failures. According to third party manufacturers, if it has undocumented behaviors, it is either error, bugs, or failures. So now what exactly is error, bugs, and failures? Now, errors are always made by human, as usual. They can be either directly influenced or indirectly influenced. Okay. Now, direct influence is when you make an error in programming, whereas indirect is the one in which some third party component makes your program have errors. And once they have errors, a bug is introduced into the program. Now, when the bug is exploited, it generates a failure. So all these three are connected: the error, bugs, and failures. Okay, now we'll talk a little bit about application vulnerability, its types, and I just wanted to know. Yeah, Pranav Sharma, do not. Uh, yeah, it is not base 64. You'll have to search for different ones. Okay. I just wanted to know if you guys have installed Linux with you today. So today we'll discuss what is design vulnerability. Now the way you design a system, it might have vulnerabilities when you actually design it. As in, even before implementation, your system might be vulnerable based on your idea of the system that you want to design. One of them might be the lack of authentication and authorization checks. Uh, Another might be error trust assumptions, as in you just simply assume that these two components are trustworthy, and it might make your system vulnerable. So even before implementation, your system still can be vulnerable. It's just that only when you bring it into life, you'll be able to exploit it. Now then there are implementation vulnerabilities. Now implementation vulnerabilities are the one that are there after implementing it because they were not able to correctly handle unexpected events. It might be either unexpected events, behaviors, unexpected errors or exceptions, unfiltered output, and unexpected interleaving of events. Now, unexpected interleaving of events is uh, the time at which two events take place might also be the case for your vulnerability to be exploited. Okay, we'll see one of the attacks today. We'll just discuss that attack. Okay, so we did see this example, right? So in a general 32-bit or 64-bit registers, if there is an int and you try to take out the absolute value of that number, so there is an implementation vulnerability because it doesn't handle the int min case. Okay. Now, then there is the deployment vulnerability where, say, you do not have correct security configuration, and due to misconfigurations, your applications have vulnerabilities. It also might be able that you have weak passwords enabled so that guessing passwords is also possible. Then there might be reset as in password recovery mechanism, which is very weak enough. So all this contribute towards deployment vulnerabilities. Now, before going to actually exploit a binary, you should know how a life of an application works. So basically, an author writes the code in high-level language. Then it is transformed into some executable form, which either might be through interpretation or compilation. Then the application is loaded in the memory, the application is executed, and at last it terminates. Okay. Now we'll go a little bit through the assembly languages, but actually we'll not be doing today's hands-on with this, but tomorrow will be actually like I thought I would do actual buffer overflow today, but it would really take too much time. So I thought of introducing a little bit of assembly language today, and tomorrow we can perform the actual buffer overflow. But we'll still be performing the low versions of buffer overflow today on the hands-on sessions. So the x86 registers. So x86 is, I guess, 8086 processors, and 64 is the 64-bit version of that processor. So these contain generally 16-bit general purpose registers, which are these ones. So RAX is generally called, so the convention is that RAX is called accumulator, RBX is called the pointer to the data, and so on. Okay. Now, RAX as one register, which is a 64-bit register, is divided into two 32 bits parts. So the first part is known as EAX, and the second part is known as EBX. Now, EAX is further divided into two parts, AX of 16 bits and BX of 16 bits. Now, AX is further divided into 8 bits, which is AH, and AL, which is A low and A high. So as you can see, if this is a data that you have, okay, now say RAX has 1, 2, 3, 4, 5, 6, 7, 8, 9A in hexadecimal as data. Now we'll just consider, so this might be 64-bit, but here it is not, right? Now we'll just consider the first 32 bits from right. Now the first 32 bit is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So as every number in hexadecimal is represented in 4 bytes, sorry, 4 bits, you can have 8 characters in hexadecimal to represent 32 bits. Okay. That is the reason EAX is from 3 to A. Now EBX will be all zeros followed by 1, 2. Now in AAX, we further divide it into 16 bits, which is 4 characters. And that is the reason 7, 8, 9A is in AX, whereas 3, 4, 5, 6 will be in BX. Now AX is further divided into two parts, AL and AH. So the high part and the low part. Along with the previous 16-bit general purpose registers, these ones, we have some special purpose registers called RSP, which is the stack pointer, RBP, which is the frame pointer or the base pointer, and EIP called the instruction pointer. So the stack pointer is the one which contains the current value of this place where you can insert the stack into, as in the a place where you can put the value into the stack is what the stack pointer currently holds. Now, RBP is a pointer which points, as in it contains data. So when you call a function, it basically needs some space to store its local variable, right? And when it is being called, it is allocated some space in the stack. Now, once the function is terminated, you really don't need that space. So you will have to go back that space. And to understand as to where exactly to go back, RBP is used. And EIP is used to understand what the next instruction is, as in where is the next instruction stored. So we'll go a little bit advanced tomorrow to actually understand how buffer overflow works. Okay. And as we have already seen the Endianness, so in binary exploitation, you really have to consider the Endianness of a system in order to actually crack it. Say you have a 32, we'll just recap this one. Say you have a 32-bit integer of 03020100 starting at this address. Now, since Intel uses a little Endianness ordering, it will be reversed in 32 bits, right? So this one will be the first to be registered at this address. The next address will be containing 01, the next 02, and the next 03. That is what I have represented. The left hand side are the addresses at which these data is stored. Okay. So we'll come to types of attack and its classes. Now there are three types of attack classes, general three types of attack classes in application security. One is file access attacks, the other one is command injection, and the third one is memory corruption. Now, file access attacks are the ones which uses users input. Say user want to pass on a path of the file or a file, and somehow he is able to manipulate what the system did not intend to do. The first one is the path attack. Okay. Now, what path attack? It is also called as dot dot attack, and you'll know why is it called so. Now, say you have that small snippet of code. Now, what this does is these are basically in C, so I guess you should be able to understand it. So, what this does is it creates a variable path and it stores a value which is a string concatenation of a string concatenation of length n of variable a, of variable b, of size, some free size. Now, basically, what an application would do is it would ask for the user file, it would append to this, and then the next command is open the file in read write mode. Okay. Now, the user might attack the unsanitized input that is directly used in this to traverse the directory. So what if he uses dot dot slash? Basically, what the application wanted to do is limit the user to the directory of foo. So there shouldn't be any case such that the user can go past that folder. But since the input is not sanitized, the attacker can go. So we'll see how it can. Now, this is a path. So these two lines we have seen. Now, what if the user provides the user file as this? So dot dot slash etc slash password. Now, etc slash password is a file which contains users and it's basically the access of the users, but it doesn't actually contain the password of the users. It is actually stored in the shadow file. Now, if this is the input that the user has provided to the application, what it does is it directly appends to the first argument. Now the actual path becomes dash home slash. So now these two are negated because of the two daughters here. So it becomes slash home slash etc slash password, and that is being written and opened. Right? So this is a bad implementation of an application. And since the user is using these two dots, it is called dot dot attack. Okay. Now we'll see this in hands-on. As in, what I'm trying to do is we'll do all the hands-on in one go so that we'll be able to understand it pretty easily. Now the lesson learned from this is never enable the user to directly influence the input and the what do you call path in which you are creating a file to be opened. Okay, so always heavily sanitize what the input is provided from the user. The next thing is path and home attacks. Okay, so path and home attacks. So this is called a tilde. So in Linux, this tilde is a shortcut to the home directory. Now, by home directory, what I mean is, okay, you'll understand. We'll just discuss this. So when you do cd tilde, you basically go to home directory. When you do cd tilde slash documents, if there is a documents directory inside home directory, it will go so. And same is the case with the desktop one. Now, what if I change the meaning of tilde? Now, tilde is generally a short form for this variable. Now, what if I make the home variable itself something different? Okay. So, what if I say the home variable is now slash etc slash? Now, if someone has implemented the system using this symbol, assuming it will always be a normal home directory, there is a vulnerability in their system. So the thing is, we'll even see this attack today. Now the thing is, you should never use home relative paths in your application security, as in, sorry, application development. I mean home relative, I do not mean relative paths. So you shouldn't use the tilde to actually implement your system. Better try to use the absolute paths while executing external commands. The next is TOCTTOU attacks, which means time of check, time of use, and time of attack. Now, will not be you as in doing hands-on on this attack, but it is good to know this how this attack works. So, what this attack does is it exploits the time that an application takes to test a file and then access a file. So, time of check is say T1, where the application validates an assumption on the file. Now, time of use is where the application is being actually used or accessed. And the time of attack is, say, where an attacker is trying to attack the file. Now, to achieve this attack, what you have to do is you have to attack in such a way that your timing should be in between the time of check and time of use. Okay. So, what you generally do is you have a assumption that A is valid, it checks and it says, okay, it can be used. What you then do is you make the A invalid and then you proceed with the file opening or the access of the file. So, okay, we'll look into command injection also. So, we'll be doing command injection today. So, what are command injections? So, command injections are something that you have a function which runs a command on your behalf on the system, and you have to provide an say a basic any command. So it is generally not often that you provide the whole command as such, but you provide an input to that command, and then it concatenates the whole thing and then it executes. So we'll see an example. Now this is a C file. You have a character string of 1024 length. What snprintf does is it concatenates. It is similar to sn string n concat. So snprintf takes the first argument as the variable itself, the second argument as the size of the variable, and rest all following arguments are concatenated and are stored into CMD. So now CMD contains this whole thing appended with whatever the first argument that the user provides while running this program. The /0 is to make sure that it is a string which can be executed in the system. Now, basically, people would do system call with this CMD as the command. Now, this is very bad because you'll understand why is it so. Okay, now we'll do the hands-on of traversal attacks, path home attacks, and command injections. Okay. Okay. So, any doubts until now? If you have doubts, you ask. We'll do the attacks. I guess you guys have no doubts, right? Okay, fine. If you guys have doubt, do ask. So what we'll do is, so I guess if you guys can open your, so I've shared a link for the files that I'll be using today to demonstrate the exploits. I've shared it on Slack, so do use it from there. Give me a second to bring my screen back. Okay. It will take a minute or so to bring up my screen because I've asked them to accept my approval. Yes. Good. So I guess it is visible. Yes. Okay. So we'll be doing a traversal attack, a path home attack, and command injection attack. Okay. So we'll be doing the home attack here. We'll be doing system calls. We'll not be doing protostar. We'll not be doing overflow. We'll be doing login. Okay. So first, let's do login. Okay. So we'll proceed with this example. I guess you guys are able to see my. Okay. Okay. Now we have two files called login.c and the executable for login. Now try running ./login. What is so? Now think that you just have the executable file login, not the login.c as in the code file. What I mean to say is, okay, what I mean to say is, So I don't know why that thing is executable. Still. Okay, we'll proceed with normal thing. So when you do this, I mean, when you run the application, what you get is enter your username. So you basically enter your username. So say my username is enter your password. Okay, it says try again next time. Or we'll try again once again. Root. I guess I've given a wrong password. Okay. So it tries try again next time. Now, if you do not have the access to uh, this code of what the file will look like, what you can use is basically a disassembler which will look later on what exactly it does. Or else what you can try to do is there's a command called strings. So we'll understand what string does now. So type man, which gives a manual for strings. Now what it says is it prints the strings of printable characters in the files. Now that is quite easy to understand. Say if you have a file here, hi there, and you give it to text.txt. Now, if you do strings of text.txt, since the contents of the file are all strings, it prints out each and every string. Now, what we can do is we can try to do strings of dot slash the executable file. Now, since it is an executable file, it has multiple data, right? As in multiple strings that are readable. So it prints most of them. Okay. So if you see from below, you see that there are something called as dot files. So dot comment, dot basis, dot data. So these are all some of the sections for the executable file. So we'll just go to a place where it isn't a dot file. Okay. So we encountered this one. So the next comes underscore files, which are still not good for us. We'll go to one that we can really understand. Okay, so we try. Okay, so what we find is there is enter your username, right? Now this is what we are able to see in when we do the when we execute the file. We even see enter your password when we do execute the file. Now it might be the case that these two are either the password or the username. So let's try using Secret Santa, and this is a gift. So we'll run it once again with this is a gift and Secret Santa. Okay, so it might be the reverse way. So it might be Secret Santa here and this is a gift. Okay, so we might be doing some mistakes here. We'll just look into what we can do is we can just simply copy it, paste it, okay. I'm not sure why is it providing me with the login. We'll just look into the file itself. So that login.c. Okay, I'm not sure why this isn't working. So it should basically, when you provide username as this and password as this, it should basically work, right? I guess I did some mistake with coding somewhere. I'm not sure if you guys will be able to find it. Okay, so we can rectify this and do it tomorrow also. So we'll go on to look for the ones that are system calls. Now let's go to system calls. Now we'll see what the system call does. So cat system calls.c. So what system call does is, as we see, it takes an argument 1, it appends to a file, and it just basically reads it, right? Now what it is doing is it is reading it from the etc file, etc folder. So we'll try to look into a file which is there in etc. This is too big. Now we'll go to cd home, we'll go to cd slash etc, and we'll see what are all the files. Okay, so there is a file called aliases. So we'll try to use that. So we'll run the file of system calls with initially with nothing. So it says please specify an argument. Then we'll try to run something that is invalid. It is saying reading your file. There is no such file or directory. Now we'll try to provide a correct one. Okay. Now aliases is a file in etc slash aliases, and this is the content of etc, right? As in etc slash aliases, and this is what the system intended to do. Now we'll do two attacks here. One is the dot dot attack and the other one is code injection attack. Now since we'll look into the coding. Now since this argument 1 is not sanitized and it is directly concatenated with the first argument of snprintf, what we can do, and then the command is directly run using the system function call. So we can exploit it by saying alias. What colon does is it makes the end of first command, then we can start a new command by its own. Say we say cat slash etc slash pkasswd. Okay, so as you can see, along with the aliases that you had, you even got the cat. So what you did was you actually ran this command such that the system was unable to differentiate between one command or two commands because it didn't actually sanitize the input. So it should have sanitized either using the colon or the slash or something else. Now this is basically code injection. So using this, you can actually do anything. Say if you want to do, what else can you do? ls. So you're able to see the ls here. Okay. Now if you want to do change directory itself. We'll try to do change directory. Okay. Now, as you can see, you were initially in the system call, right, when you ran this command. But since your input was not sanitized and you use cd dot dot, what it made was it became two different commands, and now you are in the parent directory of system calls, which is hands-on. So the lesson here that you have to understand is never use a system call that is directly related with user's input. What I mean is, here there is no sanitization of arg1. It is directly appended to a variable in cmd, and this cmd is directly run with system command. Now say this system dot calls executable has a admin level privileges, and if you can exploit it, now you would have escalated your privilege into an admin level privilege. Right? So next time you use a system call, make sure you do not have a way for the user to directly influence your input. And if you do so, make sure you sanitize the input. Okay. Now, what we can do here is we'll do a dot dot attack and we'll see if that works here. Now, we'll go to our system calls and we'll see once again how it is implemented. Okay. Now, since we are in etc folder, what it meant was it will only read the contents of etc. But say we want to read something more just than etc folder. So we'll see what is all there in. So where else do we see much more? I guess we can go to home. Okay. So what we'll do is we'll go to home and we'll see what all are there. Okay, so there is nothing in home. Else what we can do is we can go to var, we can go to www. Okay, we'll do info.php as a output. So what we can do is we'll try to run this command. Okay. Now we'll use a dot dot attack. Now what a dot dot attack does is you are currently, if you see this thing, you are currently inside the etc folder, right? So now you want to go back from the etc folder, and now we have actually reached the home folder, the root folder. Now from root folder, you need to go to home folder. From home, you need to go back to, okay, it's not home, it's var and www. And www. And then you want to read info.php. See. So we've actually used the directory traversal attack or path attack using the dot dot attack. Now, all this depict that you should always sanitize users' input before actually implementing it. Same is the case for web security that we discussed. So if there is a web application that does some manipulation on a file, you shouldn't be able to access their home directories using the dot dot attacks. Okay. Now this was one way to go. Now we'll see is, okay. Now we can see home attacks. Okay. Okay, and we'll run the home. Please specify an argument. Let's see what actually the tilde does. Okay, so what it does is it tries to open a file called test.txt, right? So let's try to modify that code into something more easy to read. Okay. So we'll modify this into just that, and we'll keep it testing slash. Now we'll compile it to the C dash O dash. Okay. Now what we can do is we can try to run this thing with some arguments. It says cat slash root testing this thing. No such file or directory is present. Right. So we'll go to home page. And as you can see, when I actually went to this tilde, the place we are currently is in the root folder, right? And that is why it said from root and then testing, it is not able to find it. So we'll go back to desktop. We'll go back to hands-on and we'll go back to home. Okay. Now we'll actually create a file in the home directory. So we'll make a directory of testing so that we'll be able to read it. And we'll create a file called text.txt. Okay, and then we'll put this into text.txt. Sorry. Now we'll say if we have oh, I forgot to put into testing.txt. Okay, so we have a file of text.txt inside testing, which is in our home directory, right? So now we can try to read text.txt, and it says testing as an attack, so it is able to finally read our file. Now, what if I actually change the meaning of dollar, as in the tilde? So say right now the currently tilde is, we'll say what currently the tilde is. So tilde is a short form for the environment variable called home. Okay, so we'll see what the home represents. Now the home represents slash root. Okay, now we are currently inside root. We'll create a directory called do not touch, and we'll have a text file inside this, which is echo not trespassing into do not touch don't.txt. Now the thing is, if I change the variable of home, okay, say home, I make it as root slash what all are in root. There is desktop, right? Disks. No, it's root dot do not touch. Okay, and then I export home. Now we'll see what home contains. Okay. So print env and home. Now home contains root slash do not touch. Okay. Now we'll try to access. Now what our code does is this actually has become a file that is represented by do not touch, but it was not meant to be so. And that is the reason we have bypassed his implementation using the tilde attack. Now what we can do is we can try to run it. Dot slash and what was the file name that we created? Don't.txt. So we'll try to read test.txt and it should say it is not available. Okay. So as you can see, test.txt is not available, right? So we'll try it doing with don't. Okay. So we are getting an error because there are two slashes here, right? So after don't touch, there are two slashes. So we'll have to change the home directory once again to this. Since there was multiple slashes, it was not able to. Okay. So now we'll try to read it back. Okay. So there is nothing called as testing in it, right? So what we'll try is we'll do a dot dot. Still there is no file in it. Okay. We'll just see why this isn't working. ls dot. So okay, so it's too much time and we'll do this tomorrow also. And I'll go to the actual buffer overflow, the minified version of buffer overflow today, and we can do the main version of buffer overflow tomorrow. Okay. So we'll just leave this here and we'll just proceed over to our binary exploitation. I'll just share my screen to give me a minute. So, give me a second. Were you guys able to do the system calls? Like, were you able to try something by yourself? I'm trying to get my screen back. I'll just ask them to accept my screen request. If you guys have doubt until then, you can ask if you have. I'm not sure why they aren't actually accepting my screen request. Okay. If they aren't able to accept, Else we can continue this tomorrow also. If you guys do have any doubt, you can ask me. Okay, okay. My screen is back. Okay, so we'll just go through the slides and we'll do the hands-on tomorrow. Okay. Okay. We'll go to basics of. Okay. Now we'll go to basics of address management in 8086. So move is one of the important operations, and you really need to know that. So the first argument to move is the source, and no, sorry, the first one is the destination, the second one is source, but it is dependent on the way you're looking at the code. Okay. So you can look it into two ways. You can exchange those values, and you should make sure that you know what refers to which one. So here, the content of RBP minus 8 is stored into RAX as a register. Here, the address which is pointed by RAX, the content of that address is stored into RAX. Here, the value of RAX is stored in the memory address of RDX plus RCX. And similarly, you can understand these two other things. Now, along with move, there are multiple operations, say exchange, push, pop, which are data transfer, and not or are logical ones, and the rest, these ones are binary. Now, disassembling is the process in which you can understand how to, as we have seen, the strings function which prints out the string from a given file. Now, if you have the executable and we want to know the actual code, so what was the code that made this executable, you can use disassembler to do that. So you can either use Radar, Anger, IDAPRO, Binary Ninja. I personally use Ghidra, which is an open source in Linux. Okay. Now say this this is a small snippet of C, which there is a character string of 100. So character string buffer of 100. But you are asking the user an input. What if the user provides a value which is more than 100 and you're trying to copy 200 values into the memory? Now, this is where buffer overflow occurs. Okay. And the root cause of it is memory copy is also not a safe implementation of memory copy. Plus, you are trying to copy 200 bytes of data. Along with that, you are not sanitizing the user input. These are the multiple causes of buffer overflow. So tomorrow we'll be actually looking into how to attack, as in how to exploit buffer overflows. Okay. And I'll try to make changes to the codes today that weren't working. Okay. Yeah. I guess if you guys have any doubt, you can ask. Else we can wrap this session up. Do you guys, do you guys have any doubt? Okay. Yeah. Thank you guys. Have a great night. Yeah, we'll see you tomorrow at the same time.